back to, I think, 1968. I just first started teaching, and the reason I started teaching was I had my summers off. It was good for tripping, but you know, if summers off, sometimes it's the wrong time to go on a field trip because it's very hot. The first real big trip I took was to the Baja, California, a little place about 12 hours south of San Diego called Santa Rosalia. If you understand Spanish, it's pretty good way to learn it because you're immersed in the language and the culture. First thing we did was we went into a few copper mines to see what was cooking. And copper mines have a lot of things in them besides copper. What you see in the pictures here is called native copper. It's copper that exists by itself because it occurs in its elemental nature or habit. Copper, let's see if we can do some things here. Oh, yes. So, first thing we did was go on some side field trips because we wanted to see what's happening. We were actually going down there to help my friend build his house. And this is a picture of me inside of a cliff. The reason I don't have it up on the screen is because I lost the lecture for these slides. And this is something that we posted in a museum. What I'm doing is I'm standing against this cliff, and you'll have to take a close look at this during social time. There's a rock layer that's coming up out of the ground here and going to the right, telling you which way the ocean currents were going at that time. And if you look very closely here, you will see the blue stones that had copper in them. Okay. On the other side, this is the mountain that we're looking the cliff at. This is right on the border of the Sea of Cortez because the Baja Peninsula of Mexico is between the Sea of Cortez on the east, and on the west you have the Pacific Ocean. This is the Pacific side of that hill, and the Cortez side over here on the right. This is, if you look at this picture closely, you'll see the layers of blue going through, and that's one of the ores of copper. Okay, so that's what we're talking about today, the element copper and the ores. Okay. I guess I could leave this on top of everything so you can take a look at it later. That's a good thing. Okay, moving on. All right, I could read good. Copper's a reddish metal. It's probably the only red metal, isn't it? Right?
Well, iron's considered a red if it's...
Is it? No, only if it's oxidized.
Yeah.
So, not elemental.
No.
And it's malleable, conducts heat, electricity. It's also ductile. And many substances may have metallic lusters, but they do not act like metals. And I'll show you a couple. Examples: hematite, silicon, balayite, and millerite. Just examples of coppers that bond to other elements and then the properties change. That's normal for chemistry. You take hydrogen, which is an explosive gas, and oxygen, which is a breathable gas, and you put them together and you get water. Look at the properties, how they change. Not only are they not gases anymore, but they're liquid at room temperature. So bonding copper to other things changes the properties of the copper and changes the properties of everything. That's the nature of what a compound is. And minerals can be elemental or compounds. All right, copper is found in the free elemental state, referred to as native, and we find this in Adams County, Pennsylvania. It's good to have local stuff here. So I brought in a couple of pieces of Adams County, and if you look at this, you could feel the copper in it. It makes the rock very rough, the rock really rough, because your hands catch on the copper. And if you look very closely at it, you may even be able to see some of the copper in it. And you'll also see some of the reduced or oxidized copper. Adams County just recently had, I guess within the last 3 years, that's recent, had a lot of copper discovered right on the surface of the ground. So a lot of it's weathered. When they find a good place where it's coming out of the ground, they'll probably do some mining work. And of course, copper was first used by Neolithic humans in 8000 BC, and they substituted stone So we're making things that they normally make out of stone, they make it now out of copper. So it was used this for quite a while ago. Okay, now if we take a look at copper proper by itself, it's atomic number 29. What does that mean? Anybody? What?
Number of protons?
Yes, number of protons. When you take a look at an atom of copper, most of the weight occurs in the middle with the nucleus, and the electrons are just spinning around the outside. So if the weight of the copper comes from the center ball nucleus and has 29 protons, because that's what the atomic number is, you subtract that from the weight and you will find out how many neutrons there are. Because the electrons have very little weight. They're like 1/1900 and some particles. The fraction is that small, so it has hardly any weight. The atomic weight is 63, subtract 23 from 63, what do you get? 31?
29.
Say it again?
You say 29 or 23?
Oh, it's all math bad. 63, yeah?
34, 33, 34.
30, 33, 34. Okay, so if you have more neutrons than protons. So how many electrons would you have? If you have 29 protons, that means 29 positive charges. The atom has to be balanced, so you need 29 electrons, because those are negative. So when you look at the electron configuration here, it's 2, 8, 18, and 1. You add them all up, it's got to be 29. You have to have positive, balanced, negative in an atom. Okay, and I'm giving this to you because I want you to have an understanding about why copper bonds with other elements so easily. Okay, the configuration is the first orbit will have 2 electrons spinning around. The second orbit has 8, and that's full. Okay, a full orbit doesn't bond very easily. So if you get to the 18, which is a larger orbit, it holds more electrons. Finally, that last orbit has this 1. It's so easy to get that electron to be pushed off. So something I try to remember in chemistry is this. If you lose an electron, what happens to the atom?
Becomes an ion.
It becomes positive.
Yeah.
So you're losing an electron, a negative particle, you become positive, right? So in order for this to bond, you're going to either take that electron and lose it, and that means it's oxidized. When something is reduced, that means you're going negative, that means you're going to add electrons on. See, now there's plenty of room for electrons in that outer orbit, because it's a bigger orbit, it only has 1 to begin with, right? So copper will bond, and I can't begin to tell you how many minerals there are with copper. But there are only a few that are considered ores, because in order to be an ore, it's got to have a lot of metal or something valuable in it to extract. Okay, did I miss anything here? Valence. Valence has to do with whether you're going to lose or gain electrons in the outer orbit. And it says it boils at 2,500 degrees Celsius. Remember that Celsius, not Fahrenheit. And the melting point is over 1,000 degrees Celsius. Pretty hot. Just to review copper. All right, now this is copper in its crystal state. If you get crystals like this, Steve, that's pretty good.
No, unfortunately, they're not grown like that. It looks more like broccoli.
Broccoli?
Yeah.
Just eat the top parts. All right.
Right.
It's found in a reduced form in sulfides like arsenide, chloride, carbonates. It combines with many common minerals such as malachite, azurite, chalcocite, chalcopyrite, bornite, and cuprite. I had to practice that very bit. It's hard to say all those names.
Yeah.
No one would expect you to remember them, but you should be able to remember at least the common ones. Everybody check this out? Okay. I'm sorry I only had one
The
piece.
dark part is the
I think the other
copper.
pieces are,
The dark part of the rock is the copper, like the darkish.
Greenish part.
the greenish part is,
It's
and
green
whatever
or
feels
dark?
rough would
Oh,
probably
okay.
be, because
I couldn't see green, I saw
okay,
it dark.
I have a piece of copper that we sliced up from there, and this is a little easier to see the copper. It's not always on the not always on the edge, but you can see from here.
I apologize for holding up everything.
Please, hold me up.
Wow. That's a nice piece.
Okay, so, these are just a few of the minerals that copper is found in. Okay. One of the most beautiful ones that most people remember is malachite. It's a copper carbonate, and as you can see, it forms in a lot of layers. Those black, darker layers can be copper. They can also be tenonite. They could be tourmaline. They could be hematite. I mean, there's any number of things that can occur in there. Malachite forms in several habits. They form as stalactites, as botryoidal, and fibrous. Okay. Notice it says hydroxide. That means you're adding some water to it. And it says it also forms minerals like azurite and chrysocolla. So we're talking about things that can now be used as ores. All right, this is a stalactitic malachite, pretty nice.
Yeah.
Oh,
Just funny looking, but you got an idea of where those layers come in a little bit, because if you were to slice through that, what would you have? Circles.
They
Can you
see
picture
more
it?
copper,
This is botryoidal,
more copper.
even easier to see where those circles come from when you look at the.
That looks very similar to what you were selling a couple months
The
back.
other one
Yeah, I had a
is
few.
very little,
I have a nice chunk of this, is from the Baja, actually. Okay, take a look.
oh, that's.
It's heavy too, because it's got metal in it.
Is that the Congo one?
This one, most likely.
Yes.
most likely. By the way, do you remember the guy who was selling it from the Congo? His
I
name?
remember, I don't remember his name, but.
Max. Max.
Yeah. he
Max
was
has his wife there now. Okay, and this is fibrous malachite. The crystals, there was a zone that was found within the last 5-6 years with the crystals were over an inch long. They were beautiful, and it's very rare. Copper also occurs in Lancaster County, but it's usually a crust on top of the rocks. And you can find it right along the roads driving through the farmlands, because they don't want the rocks on the property. So you can find it right up against the fence. And it's easy to find crusts of malachite, but it's not as beautiful or has the same kind of color. All right, now we want to talk about some ores. Malachite is turned around a little bit. It's become more of a fashionable stone rather than an ore, although they're still mining it. I have a few pictures of malachites that are found in Arizona. It's just either can be a natural rock or sediment that contains a valuable mineral or metal, and usually above background levels. It usually it's extracted for profit, and that's what copper is. And the grade of the ore refers to how much of the copper you can remove from the rock. Just basic common stuff. All right. So now we want to take a look at some of the ores of copper. Good to be familiar with. Okay, this is chrysocolla, a hydrous copper phyllosilicate mineral. And what phyllosilicate means is the silicates are the largest group of minerals that there are. Why? Because silicon and oxygen are the most common elements in the crust of the earth. So if you have more silicon and oxygen, you're going to have more silicates. And in this particular mineral, it's usually brittle and powdery, and with chrysocolla, if it does occur as a very fine powder, it can infuse itself in other minerals. So it's possible to have something like a chalcedony or a silica with chrysocolla in it. In this particular picture, above my head is chrysocolla infused in chalcedony, and it was considered a gemstone. So I brought home about 200 pounds of this on a plane. Almost killed the.
Is your pockets?
the girl who was trying to help me out with my bag, she didn't realize how heavy it was. And this is, if you take a look at this and just turn it in the light, you can see it has a natural luster to it. It's a beautiful color. And it came, I had pieces of this which were white, black, and blue. And the black was the hematite infused in the chalcedony, and the white was the chalcedony itself, and the greenish bluish is the chrysocolla. Now, chrysocolla, as you can see here, has a little bit of a greenish tint on the top. This next picture shows you a little bit better about how the colors intermix, because it's all chrysocolla, okay, and it just, the color varies, and it's misleading to say I can identify something by color. That's it is a chrysocolla. So remember, the piece that's going around now is chrysocolla chalcedony. So it has a hardness of 7 because chalcedony is quartz, and it's basically a stone that can be shaped and faceted and do whatever you want with it, and the polish is amazing. Although I wish I had a polished piece here. This is another piece of chrysocolla. You can see the grade of blue and green in this particular piece. It's heavy, so watch your fingers, don't let it drop. And you can also see that it occurs with azurite. Okay, you can see the blue on the top. Nice chunk. Okay, watch your hands. Okay. I'm trying not to give you anything that's caustic or poisonous. It's a carbonate. You chew on it if you get hungry. Okay, so it ranges from blue to green. Chrysocolla.
Need your vitamins.
I always spelled it wrong. I always spelled it C-H-R-Y-S. Chrysocolla. I kept with an A. I'll put an A in there. It's all O's. Okay. And this is chrysocolla as a stalactite. So you can see it has that same thing. I guess if you cut through this, you're going to get a whole bunch of circles also. It's beautiful.
Wow.
In this particular form, it's
It's like trees.
Oh, yeah.
like a mini forest. Very pretty, very pretty. And you know something, blue is a very big seller in minerals. It's a big seller. People want blue jewelry. They want blue stones. Okay. Is it fluorescent?
Pink.
It's regular light.
Regular light.
He's got a
Okay.
fluorescent.
Just checking.
Yeah, he's got a fluorescent.
Okay. Copper walls can also be weathered into a bluish color, and as well as green, and that's your azurite. And it's also was known as chesylite, and it's also a basic carbonate mineral. So
Wow.
it's considered. I think this is a little blurry in this picture. This is from Morenci Mine in Bisbee, Arizona. I hope you get a chance to go there. They usually have tours and they allow people to collect there, so it's a big concern.
This is
And when you get closer to the crystals, crystals of azurite are
Oh
beautiful,
my God.
and they have such great luster. I sold 2 pieces of this past week. Those pieces I had on the table were sold. Remember the blue ones? Gone fast. People like blue. Okay, and those I got at from the New York auction. Next is chalcocite. CH is pronounced K for Greek-speaking people. And it's a copper sulfide. Notice it has a slight, if you look closely, it has a slightish blue color, but it's a very silvery color. I almost can look at it and I see pyrite when I see it, but it's a various, the luster is all metallic, but it's got variation in color. You have a chalcocite here. You can see the crystals better on the right side. They're very dark black, and that other piece was turned around over there. It's hard to see or recognize chalcocite most of the time. And we have covellite. Now covellite has definitely more blue color. The blue has variation in it. Covellite is more sought after. It's a little more rare. It's just a copper sulfide. It's a hardness of 1.5 to 2. That's kind of soft. It has a black streak. The crystal structure is hexagonal, metallic luster. It's opaque. And it's got a perfect basal cleavage. It has fracture, uneven or irregular, and It does exhibit pleochroism. Anybody know what pleochroism is? Robin?
Was she an empress in Rome or something like that?
Pleochroism? Nobody? It's like a iridescent chrome color. It varies in when you turn it, you see a change in the light color. Pleochroism. It's a more sought after mineral.
Can you leave that, can you leave that again?
You want me to
Just
go
so I wanna
back?
Yeah, I wanna just read over it again, please.
Basic stuff, you can look it up if you need it. Or you're looking at the crystals.
No, I'm reading.
Aren't the crystals beautiful?
You are, and when you were saying.
But you know something, it's easy to mistake that for azurite. Take a look at the
Yeah,
top one.
yeah,
Isn't it
yeah.
look like the azurite
That's why I'm
crystals?
trying to read over this, cause to identify better. What did you say about the cleavage though?
Basal. 0.0001 is a basal cleavage. It
Okay,
means,
this isn't
we're not
light
talking
shining.
about crystal, we're talking about cleavage. Cleavage is how it breaks.
Right,
When it has a basal cleavage, that means it cleaves in one direction, only one direction.
yeah.
Hmm.
I
For
could see
one-
that on some of the pieces
For
you
one
showed us.
grain. If you have several grains, the cleavage could be different. There's only one direction, a way it's gonna break, the atoms are lined up, and the weakness is only one direction, so it only breaks in a flat surface, and it's usually got a luster on that surface, so that's how you tell when there's cleavage. Good, all right. This one is interesting. Cobalite is also known as indigo copper, and as you can see in the pyrite there, it just stands out. So
Wow.
you're really easy to tell when it's like that. Okay, it occurs in pyrite a lot. So, and cobalite crystals. I don't see the crystals here, but I think I'm looking for a flat geometric size. I'm not seeing too much here.
I think it's more iridescent cobalite than the other one. The
Chalcocite?
yeah,
No, the cobalite is the one that's bluish.
yes, but it's iridescent, so.
Yes.
Yeah,
Oh, you can see it here.
yeah,
What does it remind you of?
peacock,
Yes. Or
yeah,
chalcopyrite.
chalcopyrite.
Yeah. Okay.
Oh, some chalcopyrite.
And guess what? Bornite does the same thing. You could really get messed up trying to figure out whether you have cobalite, or bornite or chalcopyrite. Did I mix that up? Too many names. All right. So here's another copper iron sulfide, bornite. Do I have any more bornites? Yeah, another bornite. When I look at that, I see chalcopyrite. Easy to make a mistake, because you could also see pyrite in there. It looks like it has pyrite.
That's what I was thinking too.
By the way, a lot of pyrites, when you look at the periodic table of elements, copper and iron occur very close to one another, so it makes sense that they would form in the same mineral. Okay, so most of the minerals you have shown are used as ores of copper, usually destroyed in the extraction of the copper, and the other element might be iron, might also be collected, but you have to remember also that the other elements are left behind, and one of the most common elements left behind is sulfur, and if you leave sulfur in a pile outside, it's going to turn to sulfuric acid, which is not good for the environment. Most people who do digging know if they hit a pocket of pyrite, they should cover it up. Okay, it should not be left out for weathering, because that really makes it difficult for everything else. And at the bottom here, I just took a list of minerals that have copper in it, starting with the letter A. And if you could just pronounce all those names, you're good. Just try it. Agardite, actashite, alulite, algadonite, archibisite, arthurite, aricupride, and azure spar. All of those are minerals that contain copper, and it's only starting with the letter A. If you went through the alphabet, you'd end up with hundreds of names. Okay, so I just wanted to leave you with that. Okay. And mines in the United States, Morenci, the largest copper mine in Greenlee County, Arizona, good to visit. In 2023, estimated 400,000 metric tons of copper. Kennecott Copper Project in Rio Tinto produced 169,000 metric tons of copper. And Safford Mine in, that's Utah, isn't it? No, Arizona. I thought I had one in Utah. Never
You
mind.
do, up at the
Kennecott's
Rio
in
Tinto.
Utah.
Oh, that's Utah. Okay,
Yeah.
I'm sorry. Yes, all right. And Arizona Safford Mine produced 124,000 tons of copper. Okay.
I
Sounds
thought
like
a
a
lot
good
of copper
project to
came,
get into, doesn't it? All right. So-
I thought a lot of copper came from the upper peninsula of Michigan.
Well, these are the
Iron
larger
mines.
mines.
All right,
Yeah, I think the copper in Michigan is like collectible native copper. I don't know that it's really like
I don't
a-
think they're mining it in Michigan.
Yeah, well, I mean, that's where all the native copper comes, the beautiful, beautiful crystals. But I mean, I don't know that there was enough there economically to like make huge
Commercial
mines.
mines.
Yeah,
Yeah,
I mean, that's a collector's haven.
I
just
left
to
a
go
few
with the
pieces of
museum.
copper in the.
Actually, there were mines of
Okay.
copper.
Probably.
So let's take a look at this
But
just
not
for a second.
industrial.
This is a vehicle, a bulldozer that's used to push rocks around. This hopper here, when it lifts up, can hold a ton of rock. And what is a ton? Over 2,000 pounds. So at $124 for 10 pounds of copper, that's what the market value is, processed. Think about what you're making every time you scoop up copper ore. You have to, it's not pure copper, it's like finding gold. Gold is not pure gold when you find it outside, it's mixed with other things. So you have to go and process it. And of course, the truck itself is really expensive. If you take a look at and put a 6-foot man in here, average size, he's smaller than the tires. And when I asked him how much a tire on a truck like that costs, he said it's over $10,000. So we're talking, there's a lot of money spent in this kind of equipment to mine copper or anything else that is quarryable. When you think about it, you really have to keep it moving. You have to keep the rock moving, and 2,000 pounds would be 200. 2,000 pounds. That's put 10 pounds in there. That's 200.
You know, reserves.
200 pounds, right? At $124, is what the
24,000.
$24,000, about $24,000 every scoop. Now here's the kicker. A lot of these copper mines are claiming copper, but a lot of other minerals occur with the copper, naming gold and silver as well. And the gold and silver may just go right in their pockets because they don't have to claim that, they're a copper place. So
What is the copper used for? Is this the pipes and stuff they make?
everything that,
I mean, I wear copper jewelry.
Electric.
anything that's
The
copper,
electrical, right, wires and stuff, yeah.
So he scoops it up in his bucket, he's got a bucket of rock.
yes.
What's the process to take it from rock to copper?
Well, first they crush it, and then it may go through baths and things to remove all the grain. You have to remember, with certain products, sometimes it's easy to draw it out because its properties are different. In the case of a copper, they may just hammer it and the copper will flatten out and it'll pass through and everything else will drop through the holes. So that's one way of separating. It's just there's density separation. We were working separating a beach sand on the beach of the Sea of Cortez, and we were finding gold in the beach. The beach was literally filled with gold, and the problem was it was just so hot there. It was like 120 degrees in the shade, and we couldn't work in the sun, and then you can't work at night because you can't see very much, so it has its logistics to overcome. I spent maybe 3 months there, and it paid for the trip, that's for sure.
And of course, sulfides are much
Oh.
more expensive
Oh,
to refine because you gotta get rid of the sulfur.
Yeah. Now, you're talking about the different types of copper ore. For electrical grade copper, right? What they do is they mix the sulfide with it, or it's in there, but they have to extract that copper using electrolysis, just like what I'm doing to make the copper crystals, because that's 99.999% pure. You do not want any other elements in that copper matrix
Right.
because that causes a hot spot. And that's what they make electrical wires and electrical components out of. When you recycle that copper, it gets mixed in with everything. And so it'll go from copper wire, etc., which is your highest quality copper, and everything after that, it just gets recycled. Now it's copper pipe, now it's copper cladding, now it's the copper on the bottom of your pot, because it all has more and more impurities in it.
Copper jewelry, they probably make a lot of copper jewelry.
Here's
And-
here's the turnaround. I really didn't go out there to do copper mining. We originally had the idea of going there and looking for some rare crystals that occur with copper ore. And what we found when we looked at the stratigraphy of the rocks is that the island or the peninsula of Baja has sunk down and submerged into the ocean 4 times in the history that is exposed on the surface. So you take this copper ore that's coming up through the lavas and places that have magma, and you put that into the ocean and bring it up, and then put it down again and then bring it up. You're going to get an interesting mix of a saline with these copper ores, and that's when you create some very rare materials. And what we did end up with are these tiny little boleite crystals. I have a couple of bags of them. I was selling them for $15 a bag. It's just a simple crystal. But what was even more rare were that we were getting a boleite crystal is unique in that it is the only blue metallic cube formed in nature. So the largest one I saw was maybe 3/4 of an inch. I sold it to a geometry teacher for $1,000. And what we were finding were, if a cube has 6 sides, we were finding pyramids of kumajite on top of each of the sides. So you had a 6-sided stellated crystal made of kumajite, and the kumajite would be the same size as the boleite, but extending from each of those 6 sides. And kumajite is completely different. It's a copper oxychloride combination, very rare, and only found in one place in the world, in the Baja. You can find boleites all over the world because copper ore does get into the ocean, but for some reason it only occurred in one place here. We were able to go down about 300 feet in the Amalia mine to gather up these crystals from the walls, so they were unweathered. We found maybe 10 kumajites, but we also found other overgrowths on the boleites, pseudoboleites and some paraboleites, and we had a collection, and I probably still have it somewhere. I haven't been able to locate it, but what also happened was we were finding other minerals replacing the boleites when they dissolved out. So you had pseudomorphs, and the pseudomorphs that came in, we had analyzed, they were anglicites. So we had a lot of interesting minerals to replace the boleites and cubes and pyramids of kumajite. And occasionally, not all the pyramids would form. We had only 2, one on each side, so it looked like a doubly terminated scalene crystal made of andesite or made of kumajite. And that's what we started to get excited about. And of course, when we came to New York, that's what we sold, paid for the trip. I have a few more left somewhere, and I have some chunks of like sandstone from this mountain that have the boleites all over it. And if I broke it open, I could probably find other things too. So that was the trip. to end all trips. I've been across the country twice to do that, and then we went to Northern California, worked for the Klamath National Forest as working forest fires, because that was profitable. Okay, that's copper and things that form.